In this lesson, we're going to look at degrees and radians, two ways to measure angles. Degrees is what we normally use. Radians is what we're going to introduce in this lesson. Very important when we get to calculus. So let's have a look at what a radian is. We draw a circle and we let the radius equal x. If the arc length is x from here to here, the angle at the center of the circle, theta, in this case theta is equal to 1 radian. So when the arc length is the same as the radius, we can say that the angle at the center is 1 radian. Now we're going to develop this further. What about if my arc length is 2 radiuses? Let me just make that an angle. So what about if this is 2x, this is x, and this is x? This theta will be 2 radians in this case. The formula in the tables is the length of an arc is equal to r theta, and it tells you in brackets where theta is in radians. Don't get confused yet. So let's have a look. L is equal to r theta. This develops it a bit further. What else can we say about the length of the arc of a circle? The full circle, the length of an arc of a full circle, you guys know from junior cert, is 2 pi r. So we can say then that in a full circle, 2 pi r is equal to r theta. So the r's cancel here and we get 2 pi would be equal to theta. And we know that 2 pi, well, we know that the full angle in a circle is 360. So 2 pi would have to be equal to 360 degrees. So pi would then be equal to 180 degrees. And that would be pi radians. So let's just have a look at some maths behind this so we don't get stuck in the whole radian measure. If 180 is equal to pi, that's what we want to think, pi radians. Now we're not going to write pi radians every time, but 180 is equal to pi in degree form and radian form. So the kind of, when we see in complex numbers, we're going to see these angles in radian measure. So what about pi over 2? Pi over 2 radians is 180 divided by 2, 90 degrees. And these are the things we're going to see most commonly. Pi over 3, 180 divided by 3 is 60 degrees. Pi over 4 is 45 degrees, 180 divided by 4. Pi over 6 is 30 degrees. So pi over, let's say 10, 180 divided by 10 would be 18 degrees. Pi over 15, 15 12s is 180, so 12 degrees. So these are just some examples of the angle sizes that we're going to see. The difference between degrees and radians, there's a connection between the two, and it's quite straightforward when we jump into some questions. If I divide both sides by pi here, I'm going to get 180 over pi. Pi over pi is 1. So 180 divided by pi is 1 radian. And in this case, pi is 3.14 or 3.142. So if you divide 180 by 3.142, you're going to get 57.296 degrees. So 1 radian is 57.296 degrees. And if you obviously multiply that by 3.14, you're going to get back up to your 180. Similarly, if 180 degrees is equal to pi radians, if we wanted 1 degree, it's a bit like converting to percentages. 1 degree is pi. If we divide the left by 180, we got to divide the right by 180. So 1 degree would be pi over 180 radians. So if we look at 90 degrees, just another way, and if we don't learn these guys off, which you will learn them off by the time you finish this topic, 90 degrees, using this method, we'd have to multiply the left by 90 and the right by 90. So we'd end up with 90 pi over 180, which you can see simplifies down to be pi over 2. So a couple of different ways to convert. So try these few of these questions from your book, page 217 if you're using active maths. And we'll move on to the unit circle in Leaving Cert Trig 3.